Hello everyone, in this video I want to discuss examples of parametric equations. So for my first example I want to show if I'm given a Cartesian equation, in this case it's just single variable function, I want to find the corresponding parametric equations of my function. And the way how we do this, you remember, you just need to take a variable x and make it to be dependent. But before we're gonna start, let's graph our function y equals sine of x. And we know that in this case it's just my sine function, so we just need to find the table. And this table we have just x and y. So we just need to find when x equals to 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when sine of 0 is just going to be 0, sine of pi over 2 is 1, 0, minus 1, and 0. So if we're going to graph this, we're going to get exactly this graph. And we can keep going, so this is going to be my Cartesian graph for y equals sine of x. And let's say for this graph, we're giving a particle at the origin, which is going to be our initial point. And we want to write down the equations that going to describe the movement of this particle up to this point. So this is going to be my parametric graph. So in this case, we can do this by translating my Cartesian equation into parametric one. So what should we do? We need to choose a parameterization for my function. So we need to set let's x to be equal to some function. In the most easiest function is x equals to t. So if x equals to t, in this case I will have that y equals to sine of t. And what we know about this function, this parametric function, we know it's going to be our initial point, and this is going to be our terminal point. And we have coordinates of my initial and terminal point. So my initial point, let's say point A, has coordinates 0, 0. And my terminal point, let's say B, has coordinates minus 1, 3 pi over 2. Actually 3 pi over 2 minus 1. We can see these coordinates from this table. So this is my A and this is my B. And then by knowing what is my x and what is my y, we know that on the right hand side I will have the t sine of t, and this is equals to also t of sine of t. And from this equation it's clear what is going to be my bounds for t. I can see that my t will start from the point when t equals to 0 and will go till t is going to be equal to 3 pi over 2. Okay, and we can see that for our Cartesian graphs, we can choose any path on our Cartesian graph, and for this path we can describe in terms of parametric equations. Okay, so this is my first example, and let's move on to the second example. For this example, I want to go opposite direction. I want to go from parametric equations into Cartesian graph. So first, let's find the graph, parametric graph, for this function, x equals sine t, y equals cosine t. And one of the most easiest way, let's actually do it by using tables. So we have not t, not x, we have actual t, and we also have x and y components. Okay, I don't need this one, so only need this one. And t, let's say equals 0, pi over 2, and pi. So for this case, I can see that sine of 0 is 0, sine of pi over 2 is 1, sine of 0 is 0. Cosine of 0 is 1, and then pi over 2, 0, and minus 1. So in this case, I will have that 3 points, and have 1, 0, 0, 1, and minus 1, 0. Where this is going to be my initial point, and this is going to be my terminal point. And as you guessed, if you're going to plot more points, you can see that graph of this parametric equation is going to be a circle, which go from point 1, 0 to minus 1, 0. Okay, this is our parametric equation, but let's find actually the Cartesian equation, and let's double check that indeed I will get upper half of the circle. And what I'm going to use here I'm going to use a really important trigonometric identity, which is sine square t plus cosine square t equals to 1. And I can see that if I have x equals sine t and y equals cosine t, then x squared is sine square t, y squared cosine square t. So if I'm going to plug in and have x squared plus y squared, I will get sine square t plus cosine square t, so I will get 1. And yes, indeed, the graph of this equation is going to be exactly a circle. But here we need to be careful, because my parametric graph is only an upper half of our circle. So what do I need to do with this equation? Since I have upper half, I need to solve this equation corresponding to y variable. So in this case, I will have y squared equals 1 minus x squared, or y equals plus minus 1 minus x squared. And since over here I have only positive y values, I need to choose a positive sign. So my final answer, my Cartesian graph of this parametric equation, is going to be y equals square root of 1 minus x squared. Okay, so in these two important examples, we saw how we can move from Cartesian to parametric, and how we can move from parametric and a Cartesian equation. This is important because sometimes it's easier to represent function in terms of parametric equation and sometimes in terms of Cartesian one. So I want to make sure that you know how to do both ways. Okay guys, thank you for watching. If you enjoyed this video, please let me know. If you're not subscribed to this channel, please subscribe. Let me know if you have any questions, and next time I'm gonna give you more examples about parametric equations. Thank you for watching.